Okay, let us now solve the question number 35. Question number 35 says, Shanta runs an industry in a shed which is in the shape of a cuboid surmounted by a half cylinder. See the figure. If the base of the shed is of dimension 7 meter cross 15 meter and the height of the cuboidal portion is 8 meters, find the volume of the air that the shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meter square and there are 20 workers, each of whom occupy about 0.08 meter cube, 300 meter square, and there are 20 workers, each of whom occupy 0.08 meter cube of volume of space on an average, then how much air is in the shed? Okay. So let us try to analyze this question. The first part of this question is asking us that there is a cuboidal factory, okay, the cuboidal industry, and it is covered with a cylindrical top, the half cylindrical top, okay, and it says what is the volume of this particular industry, of this particular building. So let us draw the diagram first. Question number 35. The diagram is as given in the book. Like this. This is the diagram, okay. So we have this as the cylindrical top. So what we have is, this is the cube, okay, this is the cuboidal portion, and this is the top, which is a half cylinder. So this is a cube and this top is a half cylinder, and the dimensions of this cube are given as 7 cross 15. So this is given as 7 meters, and cross this as let us say this is 15 and this is as 7 meters. Okay, you can take this 7 and 15, do not matter. Okay, but in the question it is given that this has to be 7 and this has to be 15. So that's why, as given in the question, that's why I need to take this as 15. Now further, I can see the height of this factory is given as 8 meters. Okay, so we have this kind of diagram. Now our task is to first determine the volume of the air that this shed can hold. So now what is meant by the volume of the air that shed can hold? We know that air will spread in every volume, okay, air can spread everywhere. So what will happen if air come inside this factory, inside this shed, then the air will occupy each and every corner of this shed, okay. So what I will say is, I will simply say that volume of air in shed is equal to simply volume of shed. Now why I have written this? Because air can spread in every corner, that's why the air will occupy the complete factory from one corner to another corner, each and every corner, okay. Not a single point will be left that will not be covered by air, okay. That's why I can write volume of air is simply means the volume of shed. Now what is the volume of shed? I can see that this shed is made up of two portions. First one is, it is made up of two portions, that is, the volume of shed will include volume of cuboid and plus volume of half cylinder. Because it is made up of two parts, so it will include volume of cuboid as well as the volume of half cylinder. Now what is the volume of this cuboid? volume of cuboid is equal to length into breadth into height. I can see this is the length, this is the breadth, and this is the height. So volume will be 15 into 7 into 8. This will be the volume of the cuboid. Plus, now what is the volume of half cylinder? The volume of a cylinder, of a complete cylinder, is pi r square h. We know this. So what is the volume of a half cylinder? Volume of a half cylinder is simply pi r square h upon 2. This will be the volume of half cylinder. Now what is the radius for this cylinder and what is the height of this cylinder? I can see this is the length of the cylinder. Okay, what is the length of a cylinder? It is the distance between the two opposite faces. This is one of the face, and there is a face at the back of this, like this. Okay, this is the back face. So definitely the length of the cylinder will be this length, that is 15 meters. This will represent the length. Now further I need radius also. I can see this is a circular shape, this is a semicircle, and this behaves as a diameter of this semicircle, which is 7 meters. So if this is 7 meter, then half of this will be the radius of this base or of this cylinder, of this half cylinder. So this is 7, so definitely half of this is 3.5. Okay, or directly I will write 7 only, 7.2. 7 upon 2 centimeters is the radius of this cylindrical, of this half cylindrical surface. So in place of radius I can write 7 upon 2, and in place of height the height will be 15. So let us calculate the volume. So volume of air is equals to, this is 15 into 7 into 8. So let us multiply 8 and 15. So 8 ones are 8, that is 10, so 80, and 8 fives are 40. So 80 plus 40 is 120, so I can write this as 120 into 7 plus pi is 22 upon 7 into radius is 7 upon 2 into radius is 7 upon 2 into h is 15. Okay, this will be the height. So pi r square h. Let us solve this. Now 12 sevens are, 12 into 7 is 84, so this will give you 840 plus, let us solve, it is 11. So 11 into 7 into 15. So first multiply 11 and 15. This 11 into 15 is 165 into 7 upon 2. This is the calculation. Now further let us solve this. This will be 840 plus, now 7 into 1 is 700, 7 into 6 is 42, 7 6 are 42, but this 6 is at the tens place. So 700 plus 420. So 700 plus 400 is 1100, and plus 20 is 1120. Now 7 fives are 35. So 1120 plus 35 will give you 1155. Okay. So 1155 divided by 2, this is the volume. Now this is the volume of half cylinder. Further this is 840 plus, let us solve this, 1155. So 11 and this is 2, so 2 fives are 10. You will have first 5, then 15, so 2 sevens are 14. Okay, so again you will have 1 and then 5, so 15, so again 2 sevens are 14, and finally you will have 1, so you need to have a decimal and then 5. So 577.5 should be the volume of this half cylinder. Further just add these two values. How to add this? The 0.5 will come as it is, then 7, then this is 7 and 14, 7 and 4 is 11, so 1 and 1 will go to 5, 6 and 11, 8 is 14. So 141.75 meter cube. Okay, this is the volume of air that is contained inside this shed. Okay, how I calculated it? I calculated the volume of cuboid, then I calculated the volume of half cylinder, which is half of pi r square h, simple. So just this is the calculation. Now further in the question it says, further suppose the machinery in the shed occupies a total space of 300 meter cube. So space occupied by machinery is is 300 meter cube, okay. Then and there are 20 workers, each worker occupies 0.08 meter cube of volume. So what about 20 workers? Space occupied by 20 workers, space occupied by 20 workers will be 0.08 into 20. Now why 0.08 into 20? It's because each worker is occupying 0.08 meter cube of volume and I have 20 workers. So just multiply this, 0.8 into 2 will give you 1.6. So 1.6 meter cubes of volume will be occupied by the workers. So if I take into consideration the total volume occupied by machine and the workers, it will be 300 plus 1.6 meter cube. So it is asking, suppose the machinery in the shed occupies a total space of 300 meter cube and there are 20 workers, each of whom occupy 0.08 meter cube space on an average, then how much air is in the shed? So what will happen if workers and machinery will come inside the shed, the air will go out, okay. So I will say that total volume of air will be equals to volume of shed minus volume of man plus machinery, okay, volume of man plus machinery. If I subtract the volume of machinery as well as the volume of man or the workers from the total volume of shed, so the rest of the shed will be occupied by air, okay. So this will give you 141, this is 1417.5 minus, now man plus machinery, it will be 300 plus 1.6, so here I can write 301.6. So this much meter cube of the volume will be covered by the air, okay. So this is the volume of air when the man and machinery are inside the shed, okay. So this is the solution for question number 35. You can see it contains a new kind of figure, that is half cylinder. We haven't solved any question till now which contain a half cylinder. So this is a special question. So half cylinder. So we have practiced this question and we have completed the 35th question. Half cylinder means half the volume and half the surface area, okay, half the side surface area, not the complete surface area. That is the concept of discussion that we will discuss in some class, okay. So first to note this, then we will continue. Okay, let us now discuss question number 36. Question number 36 says, a solid toy is in the form of a hemisphere surmounted by a right circular cone. The height of the cone is 2 centimeters and the diameter of the base is 4 centimeters. Determine the volume of the toy. If a right circular cylinder circumscribes the toy, find the difference of volumes of the cylinder and the toy, okay. Let us try to draw the diagram as given in the sheet. Question number 36. It says a solid toy is in the form of a hemisphere. So there is a solid toy which is in the form of a hemisphere. So let us draw a hemisphere. This is, let us say, the hemisphere, okay, and this toy is surmounted by a right circular cone. So at the top of this hemisphere we have a right circular cone, So this is a right circular cone. Okay, this is a right circular cone. It says the height of the cone is 2 centimeters. So let us mark the height. It is 2 centimeters. Okay. Then, and the diameter of the base is 4 centimeters. So what is the diameter? This is the diameter. This diameter is given as 4 centimeters. So the radius will be half of this diameter, that is radius will be 2 centimeters. So we have the radius, we have the height of the cone. It says then determine the volume of the toy. So I can see this solid figure is made up of 2 different solid figures. One is a cone and another is a hemisphere. So definitely, if I talk about volume of toy, then volume of toy will be sum of volumes of 2 different solid figures. We have one solid figure as cone and another as sphere. So volume of toy will be equals to volume of cone plus volume of sphere. Okay, it is a volume of cone plus volume of sphere. So volume of toy will be, what is the volume of cone? Volume of cone is 1/3 pi r square h, and volume of sphere or volume of hemisphere, volume of hemisphere is 2/3 pi r cube. Okay, so this volume will be 1/3 pi, radius is 2 square into height of the cone is 2, okay, plus 2/3 pi r cube is cube of 2. Okay, so this will give you, when you take 2 cube as common, 1/3 pi plus 2/3 pi will give you pi. So it will become 2 cube times pi, which is 8 pi centimeter cube. Okay, so this is the volume of the toy, 8 pi centimeter cube. You can solve this pi as 22/7 or 3.14 and determine the final value. Okay, now further it says, if a right circular cone circumscribes the toy. So what it says is, as in the figure, there is a right circular cylinder, it is circumscribing the toy. So how that right circular cylinder is circumscribing? It is circumscribing such that the toy is just fitted inside the cylinder. This toy is just fitted inside the cylinder, and I can draw the cylinder as this one. I can draw the cylinder as this one. So this is the cylinder. You can see the cylinder. Okay, it's clearly different from the shape of the toy. It is a cylindrical shape and it just touches the cylinder. That this toy is exactly fitted inside the cylinder. Okay, and as the diagram explains, this top of the cylinder is exactly at the top of the or the apex of the cone. Okay, that means if I try to deduce the height of this cylinder, I can see the height of the toy is equal to the height of the cylinder. So what is the height of the toy? I can see height of the toy will be measured from apex of this cone to the base of this hemisphere. So this total length will represent the height. So what this total length will be? The height of the cone is 2 centimeter, it is given, and the base radius of this hemisphere is 2 centimeter, again it is given, and we can see this height. Okay, if I draw a perpendicular from the center of the hemisphere to the ground, this will be the height or this will be the radius of the hemisphere, which is 2 centimeter. So I will say the total height of the toy will be 2 centimeter plus 2 centimeter, that is 4 centimeter. So definitely the height of the cylinder is also equals to 4 centimeters. Okay, so we have the height of the cylinder as 4 centimeters. Now what about radius of the cylinder? I can see in the diagram that the cylinder is just fitted above this toy. So what I can say is that the boundary of the cylinder are touching the boundaries of this particular toy. So that means the width of the cylinder or the depth or the thickness of the cylinder, okay, this width or the diameter of the cylinder is definitely 4 centimeters. So the radius of the cylinder will be, radius is same as that of this toy, that is 2 centimeters. Now can I calculate the volume of the cylinder? Yes, it's very easy. So volume of cylinder is equals to what? It is pi r square h, that is pi into r is 2 square into h is 4. So this will give you 4 into 4 is 16 pi centimeter cube. This is the volume of cylinder. Now what is the difference between both the volumes? Difference is equals to 16 pi minus 8 pi, that is 8 pi centimeter cube. This is the difference between the volume of the toy and the cylinder. What I can see is that the volume of this cylinder, which is 16 pi, is exactly double of the volume of this toy. Okay, this toy is 8 pi and the cylinder is 16 pi. So there is a cylinder of same height as that of toy, of same radius as that of toy, but still its volume is just double of the toy. So it means in this particular cylinder I can put 2 toys of this kind, okay, but the shape has to be different, because surface area, if I compare the surface area of the toy and the cylinder, there might not be the same relation as we have in the volume. Okay, so you can see the toy is made up of 2 different solid figures, but still the volume of cylinder is double of the toy. So this is the solution for question number 36. You can see this diagram seems to be a bit difficult, but when you start solving this question, you can see this is very simple question, just half a page you need to solve and you will get your answer. So we have solved question number 36. Let us move to 37th question. Yes, we have the 37th question. Question number 37 says, a copper wire 3 millimeter in diameter is wound about a cylinder whose length is 12 centimeter and diameter is 10 centimeters, so as to cover the curved surface of the cylinder. Find the length and the mass of the wire, assuming the density of the copper to be 8.88 gram per centimeter cube. Okay, so let us try to visualize this question. First of all, it says that there is a copper wire which is of 3 mm in diameter. So let us draw the diagram for this question, question number 37. The copper wire is something like this. Copper wire is cylindrical in shape, okay, and the diameter of this copper wire is given as 3 millimeters. Okay, this is what is given. Now, this copper wire is wound about a cylinder. So definitely I have a cylinder. So let us draw a cylinder. So this is a cylinder, okay. This copper wire is wound about this cylinder. The length of the cylinder is 12 centimeter and the diameter is 10 centimeters. So the length of the cylinder, if I mark the length, that is the distance between the opposite faces, it is 12 centimeters and the diameter is given as 10 centimeters. This is the diameter, okay, and if diameter is 10 centimeter, then the radius is 5 centimeter. This is what we can deduce. So this is the given condition. Now I started wounding this wire on the curved surface of this hemisphere, of this cylinder. Curved surface of this cylinder means this portion. I started wounding it like this, then like this, then this, and so on. Okay, like this I started wounding this wire around this cylinder. Now, so as to cover the curved surface, it means I wounded this wire on this cylinder in a manner to completely cover its curved surface. Okay, its curved surface is completely covered by this copper wire. Now, further it says find the length and the mass of the wire. So we need to reduce the length of the wire. So try to understand. What I have is, I have this wire which is of 3 millimeter in diameter. It means this 3 millimeter represents thickness of wire. Okay, this 3 millimeter is basically what? It is the thickness of wire, and it is wounded about this curved surface. So when I started wounding this wire, like this, what I will have is, for each round, for each one round of the wire, the 3 mm height of this cylinder will be covered. Okay, try to understand this concept. What I am saying is, for each one round of this wire around this cylinder, 3 mm of width, 3 mm of distance, 3 mm of length of this cylinder will be covered. Okay, what you can imagine is that what I am doing, I am basically taking bangles which are of 3 mm height and I am just keeping them one on the other. Okay, this wire is what like, if I start wounding it about this cylinder, I can compare it with what? A set of bangles in which the bangles are of 3 millimeter in thickness and I am keeping one on the other and making a cylinder. Okay, so for one single round, what I can say is, for every round of wire, 3 mm of cylinder will be covered. Okay, for every one round of this wire, 3 mm of this cylinder will be covered. So this round will cover 3 mm, this round will cover 3 mm, and so on. So they will cover 3 mm each. Okay, each round. Now, but I do not know how many rounds I need to have. So what I can say is, let we have X rounds around cylinder. Okay, let us say we have X round around this cylinder. So what should be the condition? The total number of rounds around this cylinder, the number of rounds around this cylinder should be such that the cumulative thickness of all the wires combined. Okay, what I am saying is, if this wire should be wounded around this cylinder in a manner that all the rounds, the cumulative thickness of all the rounds should be equal to 12 centimeter. If one round covers 3 millimeter of the cylinder, then X number of rounds will cover X rounds of wire will cover 3 into x millimeter of cylinder. Now how much long cylinder I want to cover? I want to cover 12 centimeter long cylinder, or I can say this 12 centimeter as 120 millimeters, okay, because 1 centimeter is equals to 10 millimeter, so I need to cover 120 millimeters of length. And for x rounds I have 3x millimeters of 3x millimeters of length covered of the cylinder. So what I can say is this 3x is equals to 120, which implies x is equals to 40. So what does this 40 represents? This 40 represents that to completely cover the curved surface of this cylinder, I need to make 40 rounds of this particular copper wire. Okay, this 40 represents, it represents the total number of rounds of copper wire that need to be made around cylinder to completely cover its curved surface. Okay, this is what I can say, to completely cover the curved surface. So if I go for 40 rounds, what is the length of one round? Length of one round will be equals to the circumference of this cylinder, okay, because I can see this cylinder is circular in shape. So every round will be of circular in shape, and for each round the radius of circle will be 5 centimeters, because the radius of the cylinder is 5 centimeter. So I am covering the curved surface, which is a circular surface. So for circular surface I need to make a round of 5 centimeters. Okay, so length of each round will be circumference of base of cylinder, okay, because it is circular in shape. So length of each round can be written as, will be equals to 2 pi r, okay, 2 pi r, radius is 5, so this will be 2 into pi into 10, sorry 5, this will give you 10 pi centimeters. Okay, 10 pi centimeters is the length of one round. Now I have 40 rounds because I have rounded this wire 40 times about this cylinder. So what I will say, total length of wire is equals to 40 times 10 pi, that is equals to 400 pi, okay, in centimeters. So 400 pi centimeters is the length of wire that is required to completely cover the curved surface of this cylinder. Okay, so this is the length, that is 400 pi centimeters. So we have calculated the length. So first part of this question is done, that is you need to calculate the length. Now the second part of this question says you need to calculate the mass of the wire, that is how much, what is the mass of the wire that is required to cover this particular cylinder. Okay, so for that let us rub this much portion of question number 36. Now you have the length of the wire as 400 pi. So what I can see is, if I completely cover this cylinder using this wire, the wire can be imagined again. If I straighten the wire is like this. Okay, if I straighten the wire, then wire is like this. Its diameter is given 3 mm. So what is the radius of this cylinder? The radius of this wire is R is equals to 3/2 mm. Now try to understand this concept. If I make this wire straight, I can see that this wire itself looks like a cylinder. Okay, if I straight this wire, if I unwound this wire and make it straight, I can see that this wire itself looks like a cylinder of radius 3/2 mm and length as this 400 pi centimeters. Okay, length as 400 pi centimeters or 4000 pi mm. Okay, or let us take it in centimeter only. So this radius is 3/2 millimeter, which is 0.3/2 centimeters. Okay, because 1 mm is equals to 0.1 centimeters and 1 centimeter is equals to 10 millimeters. This is the conversion. This is a simple conversion. So I have used this conversion to write radius as 0.3/2 centimeters. So I have this wire in a shape of a cylinder, and the length of this wire is 400 pi centimeters and the radius is 0.3/2 centimeters. So what is the volume of this wire? Volume of this wire will be pi r square h, because it resembles a cylinder. So volume of wire will be pi r square. R square is 0.3/2 square into h is 400 pi. This is the volume of cylinder. Now try to understand why I have calculated the volume, because it says that 8.88 gram per centimeter cube is the density of the copper. So it means if I take 1 centimeter cube volume of copper, if I take a small cube of copper which is of 1 centimeter cross 1 centimeter cross 1 centimeter, then its mass will be 8.88 grams. Now here, what is the volume of this in centimeter cube? This pi into 0.3/2 square into 400 pi centimeter cube is the volume of this wire. So this much wire I am using. So what is given is that 1 centimeter cube has a mass of 8.88 grams. So definitely this volume, that is pi into 0.3/2 square, or let us say this volume, let us name this volume as V1. So V1 volume will definitely have, V1 centimeter cube volume will have a mass of 8.88 into V1 grams. So finally mass of wire will be equal to 8.88 into pi into 0.3/2 square into 400 pi grams. This is the final mass of wire that is used to cover this cylinder completely. Okay, it is given because the density of the wire is given, and density is equals to mass upon volume. Okay, but we are not going to use the formula for density. You just need to understand the significance of density, the concept of density. The mass upon volume means the density is given as 8.88 grams per centimeter cube. So this means that if I take a cube of copper which is of 1 centimeter in dimension, then the volume of that copper, the volume of that cube will be equals to 8.88 gram. So I have used the unitary method that 1 centimeter cube volume has this much weight, so this much mass, so this much volume will have this much mass, and just solve this value and you will get the final answer. Okay, so we have two answers. This is the first answer and this is the second answer. So in this way you need to solve 37th question This question is very important, very interesting. So let me mark it a star for this question. Very good question, very interesting question. Okay. Okay, so you note this, then we will continue.